Hi, this is Miss Clausing. Okay, I'm just going to go through a few of your homework problems, kind of give you a guide. I'm not going to go over the ones you actually have to do, but I will go over odds that are just like the ones you have to do. If you're in my classes, you only had to do evens for tonight. So, before we get started, though, let's just do a quick review of the steps when we're talking about variation problems. So, let's see. Okay, so variation problems. Remember, any kind of variation problem. We have the first step, we write the relationship. Whoops. I.e., for example, is it a direct? We have four options here. We have direct, indirect, not indirect, direct, inverse, joint, or combined. So we gotta identify that first. So by reading the word problem and figuring out what we have. Sometimes usually it will just tell you directly in the problem. But remember, direct, the equation we would end up writing out would be y equals kx. Inverse, the equation we would have would be y equals k over x. Joint is y equals k x z. Really, we just have two variables versus in direct variation we only have one variable. And then combined is the combination of direct and inverse, so it's y equals kx divide by z. Okay, so those are we gotta identify or write out the relationship first. Okay, then we need to find k. Okay, and then we need to rewrite step one using the k we found. With k from step two. And then lastly, our last step is to solve the problem. If it asks us to find anything else, solve the problem. Okay. Using the equation from step three. Yep. This should be from step three. Okay. Okay, so those are our steps for variation problems. They're pretty much always the same. Write the relationship, find k, rewrite the relationship using the k we found in step two, and then we solve the problem using that equation. Okay, so let's go to do a few of these problems. Let's see. Let's do a more complicated one. Let's do number 5. Number 5 will be a direct relationship example. So if you're on 5, 5 is a direct. Okay, and we'll see that when we start reading. Okay, so remember we're going to underline important points and we're going to put a box around our actual type of variation. So we have the stopping distance s, so stopping distance s of a car varies directly. So I'm going to put a box around the type. Remember, I'm just going to go ahead and write up here so I don't forget. Y equals kx is a direct relationship as the square of its speed, v. All right, so I'm going to stop here. And I'm going to go back to number 1 and going to write our relationship. Okay, so if I go here, I have the stopping distance s equals k, because it's a direct relationship, the square of v. So it's going to be a v squared. V squared is its speed. All right, if your car is traveling 50 miles per hour, so 50 miles per hour is its speed, which is v. Don't get these variables mixed up. I know speed maybe looks like s to you, but it's not. Speed is v. It tells us that right there. Speed is v. Okay? And it requires 170 feet to stop. Stopping distance is s. Okay? So now I'm going to use those 2 points that they give me. I'm going to solve for k. Okay, so let me color code this. Might make it a little bit easier. Let's go ahead and just color code the whole thing. I'll just color code the whole thing real quick. Okay, so we have s is our speed, S is our stopping distance, v is our speed. Alright, so I'm going to write this equation. We have speed equals, what's this one, k times v square of our speed, which is v, so v squared. Alright, so now I'm going to go back and plug this in. It told me a car traveling at a speed, so that's my v, of 50 miles per hour, equals, or takes 170 feet to stop. So this is my S. So 170. Alright, so now I'm going to solve for K. Okay, so if we go back to our steps, I identified the relationship was direct in step 1. And now I'm going to find K with the information that was given to me. Alright, so finding K. 50 squared. And then, so I'm going to move this 50 squared over, so I'm going to divide both sides by 50 squared. Yes, you could put 50 squared in, solve it out, and then divide that number over, but, or you can just do 170 divided by 50 squared. And so on the right side, that will cancel, and it'll leave me with K equals 170 divided by 50 squared. If you put that in your calculator, you'll get 0.068. All right, so I found K. So the next step is I'm going to plug it back into the original and use that to solve for whatever it's asking me to solve for. So I have S equals, notice I'm just rewriting this exact same equation down we had in the beginning, except now I'm going to put in 0.068 for K. Okay. Alright, so now I'm going to go to the next sentence. It says, now it wants me to find the stopping distance for a car traveling 60 miles per hour. So if it's traveling 60 miles per hour, that's my speed. Remember, speed is V. So I'm going to put in 60 where I have a V. And I already have 0.068 here. And it wants to know what the stopping distance is, which was S. Alright, so 60 squared times 0.068, if you type that in your calculator, you'll get that it's a stopping distance of 244.8 feet. 0.8 feet. Okay, and that's what we're looking for. It told me to find the stopping distance when I'm going 60 miles per hour. Okay. Alright, so that's a direct variation problem, so let's go on and do one that's not direct. Let's see. Alright, let's do number 9. So direct variation, so if you're in my class, let me just give you a hint. Direct variation for your homework problems would be number 2 is direct. I'll put a D next to them. D for direct. 2 is direct. 4 is direct. 6 is direct. 8 is direct. And that's it. Okay? Alright, so then we're going to go, let me do an example of an inverse. Inverse is number 9. I'll do number 9. Okay, so the speed V of a gear, so V of a gear varies inversely as the number of teeth. Alright, I'm going to stop there and I'm going to write out my inverse relationship here. So I have the speed V, and it varies inversely as the number of teeth. So I have K, and when it's inverse, remember it's divided by, and then, oops, the number of teeth, which is T. Okay, so there's step 1. Now I'm going to plug in what is given to me to find K. Alright, so if a gear, I'm going to read the next sentence for that. If a gear has 45 teeth, so this is my T, it makes 24 revolutions per minute, so that's my speed. Speed is represented by V. How many revolutions, okay, and now it's going to ask me, that next question is how many revolutions will a gear which has 36 teeth make? Before I even get there, though, I need to find what my constant of variation is, which is my K. So if a gear, let's just plug in these two, the teeth and the speed that we're given, find K, and then we'll figure out what happens when we have 36 teeth. Okay, so we have 45 teeth is given to us. And we have 24 revolutions per minute. And I'm going to solve for K. So to solve for K, remember I'm just going to multiply both sides by 45 to get rid of this 45 on the right. So the right will cancel and leave me with 45 times 24 is 1080. I can just type that in my calculator, equals K. Alright, so now I know what K is, so now I'm going to set up my equation so that I can figure out what happens when I have 36 teeth. So I'm just going to plug this K back into the original equation, which is right here. So I have V equals the 1080 that I found for my constant of variation divided by T. Alright, so I want to know how many revolutions will a gear which has 36 teeth make. So I'm going to plug in for T 36. I still have my constant of variation of 1080 equals V. So 1080 divided by 36 gives me 30 revolutions per minute. Okay, so there's a inverse variation example. For your homework, 10 is inverse variation. And oh, where is that? It's back. And 12 is inverse variation. 14 is inverse variation. And that's it. Okay, so now let's do a joint example. Let's see. Let's do 17. We'll do 17 as an example for joint. Scroll down here. Okay, so 17 is a joint. So I'm just doing one of each kind. We did direct, then we went to inverse, now I'm going to do a joint. So the power P in an electric circuit is directly proportional to the product of the current and the square of its resistance. Okay, so let's write this equation. The power P equals, and it's a direct relationship, so I know direct is K times, and then K times the current, which is an L, and then the resistance. Okay, or wait, no, current's I. Current would be I. So times the current times the resistance squared. Okay, remember it says squared right here. So I'm going to do R squared. Alright, so there's my equation. So now I'm going to plug in what is given to me so I can find my constant of variation. Then I'll use that constant of variation, plug it back into the original, and use it to solve for whatever it's asking me to solve for. So if the power is 100 watts, so power is, and we don't have a lot of space here, so I'm just going to write this out to the side. So P is 100. Okay. When the current is 4 amps, so remember current was I, so I is 4. And the resistance is 5 ohms, and remember resistance was R, and that equals 5. Okay, so first I need to put these three variables, plug them in, and find my constant variation. So I'm going to stop there before I go on and do find the answer, or find the power when blah, blah, blah. So stop there and let's find what constant variation is. So I'm going to plug these in. I have 100 equals K, I is 4, and resistance is 5 squared. Okay? Alright, so 5 squared gives me 25. 25 times 4 gives me 100. So my k, so this will equal k times 100 equals 100. And I need to solve for k, so k equals 1, right? I divide 100 from both sides. All right, so now I'm going to plug this k back into the original. I found my constant of variation. So I have p equals, and I found my k is 1, which I don't have to write the 1 down, right? But I can. I'm going to make sure you realize that's a 1, times my current times r, or my resistance squared. Okay, so now I'm going to go back and I'm going to see what it's asking me to actually do with this information. It's asking me to find the power when the current is 2 amps. So my current is I. So when I equals 2 amps, and the resistance, so R, equals 10. Okay, so now I'm just going to plug these in, and I want to find P. So P is going to be left as a variable. 1, again, remember, we never have to write a coefficient of 1, so I'm going to drop my 1 at this point. And I'm left with I, which is 2, and R squared, which is 10 squared. Okay, so I have 10 squared is 100 times 2 gives me 200. You can just type that in your calculator. P, and it's 200 watts. Okay. So this is what I'm actually looking for here. Alright, so there's a joint. So then for joint, for your homework, just to give you a few little hints, joint would be like 16 is a joint problem. I'll put a J next to the joint one. 16 is joint, and 18 is joint. Okay, so let's do a combined. Example combined would be 15 or no, let's do, I want to do 19. It's a little more complicated. So 19. All right, so if you need to see this, you can pause and go back, but I'm going to erase some of this so we have more space. So 19 is going to be a combined example, or an example of combined variation. Okay, the frequency of vibration f of a string, the frequency of vibration f of a string varies directly. So I'm going to just show you that you should start recognizing these and be able to just kind of start writing down what's going on. So we have f varies directly as the square root of the tension. So square root of the tension. And inversely, whenever I see inversely, I should put a divide for my inverse relationship as the length. So inversely as the length of the string. Okay. If the frequency is 40 vibrations per second, so frequency is f. So if f is 40, when the tension is 25, so tension equals 25, and the length of the string is 3, so length equals 3. Find the frequency when the tension, again, we won't really go there yet, but let's find our constant of variation, then we'll come back and we'll do what it's telling us to actually find. All right, so I'm going to just plug these in. I have f of 40. Let me make this, okay. F of 40. Okay. F of 40 equals k square root of t, which is 25, over length, which is, or L, which is 3. All right, so let's just solve this. So the square root of 25 is 5, so that gives me 5 over 3 times k equals 40. A couple ways you can solve this, but we can do it this way. Actually, we'll keep it consistent with how we're doing it in class. So let's move this 3 over first. So 3 times both sides. So 3 times 40 gives me 120 equals k square root of 25. And I want to move that square root of 25 over. Let's just simplify it really fast. Square root of 25 really is just 5, right? So I really just have 5 times k equals 120. All right, so now let's move this 5 over. It's easier than dividing by the square root of 25. 120 divided by 5 gives me 24, I believe. Yep, 24. Okay, you can put it in your calculator. So 24 equals k, because these 5s will cancel. Remember, this square root of 25 became a 5. Okay, so then this is my k. So now I'm going to take my k, I'm going to plug it back into the original equation. And then we have f equals my new k I found, which is 24, square root of t all over L. And now let's go back to the problem and see what it's telling me to find. I want to find the frequency when the tension is 36, so T equals 36. And the string is 4 feet long, so L is 4. So let's just plug these in and find our frequency. So F is what we're trying to find, so I'm just going to write down F. 24, square root of our T was 36, it told me, and L is 4. Alright, so square root of 36 times 24 divided by 4. If you type this all in your calculator, you'll get F equals 36, and it's vibrations per second. Okay. So on your homework, an example of a combined variation is number 20. So number 20 is combined. Okay, just give you a little hint on your homework. Alright, so if you need to go back and look at any of those anymore, go ahead and do that. Pause the video, rewind, whatever you need to do. And make sure for my class you bring me all the evens for next class. And that is it. Have a good night. Good night.